Hey, all you cool cats and kittens. You know who you are. Hey, I'm just going to talk about arcs and chords today. So these are going to be the notes that we're going to be talking about. You notice that probably that first page of notes you have seen already, hopefully. Uh, and we are going to kind of go into the measurements that central angles have to do with. And then your project next week will probably be a pie chart of some sort. Maybe, okay, or another scavenger hunt. I just haven't decided. So we're going to get started. Um, we're going to talk about the notes. They're already filled in. And then you'll have a couple examples that I'll go with. You'll have a homework assignment and then on vocabulary, and then you'll have a homework assignment on arcs and central angles. Okay, so let's get started. We are going to begin with arcs and chords. And we talked briefly last week about what arcs, central angles are, and how the arcs are uh, used. Arcs are basically portions, like I said before, portions of the circumference. I'm going to go this way. Watch what I'm doing. Of a circle. And if you remember, the symbol for circle is just a round dot, a round circle with a dot in the middle to verify. All right, so a central angle is an angle whose vertex is in the center of the circle. So angle EAG is going to be the central angle. It is an angle that is central inside to the circle. The vertex is the center, okay? So an angle EA and G. EA and G, I'm going to get some markers out so I can trace it, and then we're going to take a look at the central angle. All right, so angle EAG, I'm going to color it in with a green pencil. EA and G. So again, when you're naming that angle, the A is the most important part of the naming of that angle. It is your vertex. So circle A and angle EAG both have A in common. That's your center. So that angle is a central angle. There's your central angle. So the intercepted arc, we can call that our intercepted arc as well. This is the intercepted arc. It is where the sides of the central angle hit the circle. Okay, so it's going to hit at points E and G. This arc from there to there is going to be your intercepted arc. So this right there is the intercepted arc. Now, there's a certain and special property that goes along with the intercepted arc when you have a central angle. So what we are going to say is that the central angle, and we're going to get to this, the central angle is the same as the intercepted arc. All right. So minor arcs are going to be between 0 and 180 degrees. So let's write that down. Measure of arc BE. So that's how you say that. The measure of arc BE is going to be less than 180 degrees and more than 0 degrees. So this red arc right here, that red arc right there is going to be, hold on, is going to be the measurement of this central angle. So in that case, we have an intercepted arc, a minor arc of BE, and it is going to equal, and we're going to talk about this, the measure of angle BAE. So if you notice, the points at where it hits the circle, B and E, are your two endpoints of that arc. The central angle also has B and E, with A being the vertex and also the center of the circle. So it takes two forms. A is not only the vertex, but it is also the center of that circle. So that minor arc is going to be less than 180 degrees. We have a major arc and we have a semicircle. So the semicircle, I'm going to put in blue, the semicircle, reminder, goes from vertex to, point to point, but it has to go through a diameter. So these BG, so if you look at BG, I'm going to do this. So BG is a diameter. It is a straight angle BAG. So this angle is a straight angle, which means its measure of angle BAG is going to equal 180 degrees, which means that the semicircle is going to go from B to G, and we don't go from A, because if you notice when you name an arc, you don't put the center in there. But what we're going to have to do, so once again, BG is a diameter. It is a straight angle BAG. The measure of angle BAG is 180 degrees, this angle. The semicircle goes from B to G, but we have to name another part depending upon which way we're going. So if we're going along the blue, we have to name another point, and that point is someplace that goes along the path from B to G. If you think about it from segment addition postulate, we did segment addition postulate before, and remember we named towns. And if you don't remember, if I had town A to B and B to C, if B was between A and C, then on the same road, town B is there. And then what we're going to look at today is if town A to B is 10 miles and B to C is 12 miles, then the total distance would be, yes, 22 miles. Okay, so we're going to talk about that. So this semicircle is going to be an arc that has the endpoints of the diameter. If it is a major arc, so a major arc is going to be greater than 180 degrees, but less than 360 degrees. 180 degrees is a semicircle. 360 degrees is all the way around. So you could go up to 359 degrees. That would be a major arc. So in this case, a major arc I said was BCE. The measure of an arc BCE. Now, I said in the other video, if you're paying attention, minor arcs have 2 letters. Major arcs and semicircles have 3 letters. You need to name that other point that goes along that arc. So a major would be, let's see here, major would be B, C to G. Yeah, let's try purple. So B, I got to go from B through C up to, E. So I'm going to go first, I'm going to go here, and I'm going to go all the way around. This would be a major arc. That is your major arc. Okay? So your major arc, arc BCE, starts at B, ends at E, at E, and goes through C. So we start at B, go through C, ends at E. So arc BCG starts at B, goes through C, ends at G. So if you have a major arc, you have your start. Now it's not going to be like that. Go through, and then your end. So that is how you're going to label your arc. You're going to have the start point, your end point on bookends of it, and then you're going to go your go through part. So the minor arc associated with central angle MHL. H is your center of the circle. So H is your vertex and your center. So therefore, vertex, center. Therefore, the minor arc that is associated, we're going to put the arc sign, and we're going to go from M to L. We do not need a point to go through because it is a minor arc. It is less than 180 degrees. The major arc would be another point that goes through it. So I did not, we did not have that. So what I would need is this would be M and L. This would be H. Let's call this one P. Okay, so the major arc, and let's call this Q. So a major arc would be anything that goes past a semicircle. So the semicircle would be M to P, and I can either go through L or I can go through Q, as long as M and P are my endpoints of my diameter. Now, if I want to go for a major arc, if I start at, let's say, M, we'll keep it going with M, and I don't want to go to P, I don't want to go to Q, but if I go through and go to L, but I go through either P or Q, it does not matter which one. If I go M to P to Q, it's going this way around that circle. Okay, so what we're going to look at is naming your central angles. So when you were going through the naming of your central angles, and this is on the 3rd page, you had these types of things. So you went from F to E, but you went through D. So you started at F, you went through E, or you ended at E and you went through D. So this would be a semicircle. Okay, so look at the other little video that I posted on here, and it is going to go over that section. All right, so we're going to talk about this stuff here in a little bit. All right, measuring arcs, page 2. Again, pause at any time that you need to fill out, and then move ahead. Measuring arcs. Arc measurements are defined by its measure of its central angle. So once I get the central angle, I have the measurement. So the measurement, this is the measure of arc LI. Okay, so the measurement of arc LI, this is going to be the same as the measurement of the central angle. Now I don't want the arc length, I just want the measurement of the arc. There's two different things. We're going to talk about arc lengths here a little bit. So if I told you that this was 50, oh, well, that is going to be 50. Okay, so the measurement of those two are going to be 50. Now let's take this a little bit further. What is the measurement of angle MHI? Well, MHI, that's that angle. That is 180 degrees, which means that forms MI a diameter, which means that M to I going through either L or N is a semicircle, which means that the measure of MNI is 180 degrees. So the measure of the central angle, this is your central angle, is equal to the measurement of the semicircle. Any questions on that one? Now the last little part of that, once again, the last little part is we got to find what this is. Oh, well, you should be able to, if you haven't seen it yet, you should be able to notice that this creates a straight angle, 180 degrees. So this is 180 degrees. If one of them is 50, if I subtract 50, I get 130 degrees. So my central angle of MHL is 130 degrees, which means that my arc from M to L, now notice I don't, because it is less than 180 degrees, this angle, this measurement of that arc is also going to be 130 degrees. Okay, so if you have a major arc, you can find that by taking it and subtracting it from, 360 degrees. The whole thing, all the way around, if you start at point M and go all the way around point H, so if you stand at H and you point to M and you turn all the way around, that's the 360 degrees. Okay? That's a rotation about a point. So if I took point H and I rotated MH around it and kept M there and traced it with my pencil, and I rotated it at 360 degrees, you would get a circle. Okay? All right. Identify and finding measurements of arcs. So this central angle is 45 degrees, which means that this minor arc right here is going to be the same, which is going to be 45 degrees. All right. Now, QRS, which is Q, starts at Q, goes through R, and ends at S, is going to be 360 minus that 45, which is 315 degrees. So this angle, if I looked at this angle, is 315 degrees. Now, I said back in the early part of September that when we're doing angles, we generally do not have to deal with angles that are 180 or more. Here's that one case in geometry that we will. You will see these used again in trigonometry when you have bigger angles. Okay? All right. So let's take a look at this and identify the type of arc and then find its measure. Oh, okay. Well, a couple things come from this. If I don't have a picture, could I determine whether it's a major arc, a minor arc, or a semicircle? And the answer is, yeah, I could. Why? Well, if it has 2 letters, it's a minor arc. If it has 3 letters, it could be a major arc or a semicircle. This one could be a major arc or a semicircle. So I would need the pictures to help me out. So let's take a look at the first one. Is that a major arc or a minor arc? Well, I need to know where B to C to D is. B around, hit C, and around to D. Oh, I think that looks like a major arc. That looks like a major arc because it goes past 180. And how do I know it goes past? Because there's the semicircle right there. All right, so if that's 100 degrees, what's the length of that? Oh, well, the whole circle is going to be 360. So if that's 100 degrees, that would be 100, which means 360 minus 100 would be 260 degrees. So that measurement of arc BCD is going to be 260 degrees. All right, pause the video. Answer those two, whether or not you have a minor arc, major arc, and then what the measurement of those are. Okay, pause that video, work on those two, Yes, we do know that 2 and 3 are already kind of narrowed down. Let's take a look at it. Okay, so M to N, 2 letters. M to N, 2 letters. I don't go all the way around. I'm just looking at this portion of that, and that portion is going to be the same as the central angle. So this is a minor arc, and the measure of MN is going to be 135 degrees. Less than 180. So the minor arcs have to be between 180 and 0. So minor arcs are between that. All right, how about W, X, and Y? W, X, and Y. Start at W, end at Y, go through X. Major, minor, or what? Semicircle. So this would be, yes, a major arc, not a semicircle. If this is 90 degrees, which makes that 90 degrees, the measure of angle W, or arc WXY, will be 360 minus 90, which is 270 degrees. So that minor arc, or major arc, would be 270 degrees. Okay. 2 circles are congruent circles if they have the same radius. Oh, okay. 2 arcs of the same circles, 2 arcs of the same circles, or of congruent circles, are congruent arcs if they have the same measurements. Oh, that sounds reasonable. Okay, let's take a look at the arc addition postulate. That sounds pretty familiar. That sounds really familiar because we had the segment addition postulate, and we also had angle addition. And the segment addition postulate stated that if 3 points were collinear, it broke the segment up into 2 smaller parts. The sum of those 2 smaller parts was equal to the whole segment. Same with angle addition postulate. 2 smaller angles, 2 or more smaller angles, add up to be the bigger angle, but those angles have to be adjacent. Just like this. The measure of the arc formed by 2 adjacent arcs, they have to share a point on the circle, is the sum of the measures of the 2 arcs. So if I'm going from P to Q to R, now that does not necessarily have to be a major arc, but that point, notice that point is in both of those arcs. So when I'm naming that, what I am looking for is P, which starts here and goes to R, which ends there. So if you notice, it bookends, just like angles. Remember angles, we had what letter do they have in common? We looked at that point. Okay, so if circle O is here and we have this angle and we have this angle, so it kind of looks like 180 degrees. Let's say that this is 180 degrees and arc PQ has a measurement of 56 degrees. What's the measure of arc QR? Pause it, answer it. Coming back. All right, measure of arc QR, which is this minor arc right there, is going to be 180 minus 56, which is 124 degrees. Okay. And then from there we can find all the other ones. Okay, arc length. Now the length of it, if I were to put a linear measurement on it, not the angular measurement on it, but the linear measurement on it. What the linear measurement is going to be is this. It says it is the ratio of the length of a given arc to the circumference. Oh, ratio. You know what ratio is, right? A ratio is a fancy term for fraction. And then you got this is equal to, well, the ratio, another ratio. So now we've just formed a proportion. We learned about proportions. We know how to solve proportions. So in a circle, the ratio of the length given of the given arc, so we're going to say arc length over the circumference is equal to the ratio of the measurement of the arc, so the measure of the arc, this arc, over 360 degrees. So this part over here is length. Both of those are lengths equal degrees. So this is the only time that you will probably see a measurement of arc length be equal to the degrees. Now, circumference, 2 times pi times r. They might tell you what the circumference is, okay, but generally speaking, if we have to find it, we're going to use 2 times pi times r. R is, again, the radius, okay? All right, so let's take a look at the example here. Find the arc length of A to B. A to B, so the arc length. So if this is 32, this is 32. If that's 54, that's 54. If I go arc length to there, then that is what? 86 degrees. Okay? So I want to know the arc length, the linear measurement. So I got the 86 degrees by the arc addition postulate. And so the arc length, I need the arc length. Find the length of that arc. So the measurement of arc AB is going to be the circumference, which is going to be 2 times pi times r, and that is going to equal 86 degrees over 360 degrees, because I'm given my 86, and my total is 360. So if you notice, this and this, if I cross multiply, I could just give that up to there, and the measure of arc AB is equal to 86 over 360 times 2 times pi, and my radius is 8 inches. So what we're going to do is we're going to find the measurement of the arc length. So I would use my calculator here. So if I take 2 times pi, pi is this. If you want to use 3.14, go for it. Times 8. So that's the circumference, the total circumference. We're going to times it by 86, and then we're going to divide it by 360 degrees. So the arc length, of AB is 12.00 inches. Now, why inches? Because radius was in inches. So if it's inches over inches and degrees over degrees, you have inches left over. Okay? So that's that one. Let's try this one. All right, you can try this one. Just remember, so you want 360 degrees. You want 2 times pi times r. You should know what r is. Here's r. You want to know the central angle, which gives you the arc length out here. So the arc length is 158, and you want to know the measurement of arc AB. So 2 times pi times 2. Figure out what arc AB is. Pause it, come back to it. Hi. How are you? Make sure you're watching this video. Okay, so you came back to it. Got that? If we cross multiply, this is what, 4 pi? I'm just going to multiply the two numbers together and give you 4 pi. And then I'm going to multiply it up here. 4 times pi. Now remember pi, we could go with what number? 4 times 3.14. And then I'm going to divide it by 360 degrees. So my arc length in units is 5, measure of arc AB is going to be 5.51 units centimeters. Questions, comments? I guess you can't ask me. Okay. All right. So let's take a look at reverse. You know, let's think about this. So what I want to do is I want to try and find all the measurements in here. And once I find all the measurements in this little circle, then I'll find all the measurements of the intercepted arcs. So if I know that this is 63, I know that R to Q is 63, that arc. If I know that the central angle NOP is 82, then I know that this is 82 degrees. All right, I need to find some other things. I don't know whether or not that's a diagonal, or a diameter, but it kind of appears to be. I also have vertical angles right here. Oh, remember those? So this would be 63 degrees, which would make this 63 degrees. Oh, okay. Well, if I didn't know whether or not that was a diameter, I do now, because that will create, because if two angles are equal, then this angle is going to equal that angle, and these two are going to create a diagonal. So there's actually two diagonals in here. So let's take 180 and minus 63. That's 117. So that angle is 117. And then MOR is 117. And then M to R, the arc length, would be 117. Still minor arcs. So now I guess got to find that little part. So you can do a couple things. You can take the whole circle, which is 360 degrees, and subtract 63, 117, 63 again, and 82, and I get 35 degrees, which would make that 35. And if I add all those together, I am going to get 360 degrees. Now, once that you have all of those set, now it should be relatively easy to see. Okay, where's N to Q? Well, N to Q is a minor arc, so it has to be less than 180. So I don't want to go this way. I want to go this way. So what I have to do is I have to add the measure from arc N to P plus the measure of arc P to Q. And here I have 82 and 35, which is 117 degrees. How about MRP? M to R to P. No, start at M, go to R, go to P. Whatever numbers I add, I'm going to add those together. So I'm going to get 117. R to Q is 63. And then Q to P is 35. So I'm going to add all those together. I guess I'll use a calculator. That's 117 plus 63, which is 180. Plus 35 is 215 degrees. Sorry about that. I moved that calculator away really quickly. All right, how about M to R? Well, we found that. M to R, it's a two letters, so it's a minor arc. Same thing with P to Q, minor arc. So that would be 35. Now if I went subsequently, what's the measure of angle P to Q, but a major arc. So I can name any one of these other letters. Let's go M. MN to Q would be 360 minus 35, right? Okay. All right, 19. So let's take a look at 19. This means that the arcs are equal. And if those, 19. If this is marked like this, then those arcs are equal. So if that's 135, that's 135, which makes this, 135, which makes this angle, 135. And the whole circle is 360. So if I subtract 135 plus 135, which is 270, then that gives me 90 degrees, which is the arc of 90 degrees. Okay. All right, over here, MQ, or MN, I want to find MN. So notice this is equal to this. I have this arc, I have this arc, and these two arcs are the same. Those two arcs being the same means that the whole circle is 360. If I subtract 365, I get 295. And then if I subtract 85, I get 210. This is for both, which means I have to divide that by, that's right, 2. So each one is 105. So this isn't a central angle. I don't have a central angle. But I guess I could if I connected T, which is the center, to those endpoints. I could get two central angles. But just be aware, these two are not going to be the same. It doesn't matter. It can still create those two angles. Okay. All right, this one is a little bit same type of thing. So this creates a chord and a diameter. This is 130, that's 130, which makes this, what did we say, 260. So from 360, the whole thing is 100 degrees. And then each of these would be equal to each other. So 50 degrees. Okay. All right, so go back through. I'm going to post these up. I want you to go back through. Arc length, there will be a few questions on arc length with the given angle measures. I want you to do the other worksheet on the vocabulary, and then I do believe it might be Delta Math. Check your Delta Math, and I will put up that assignment as I see as well. So you're looking for May 11th through the 13th. You got note packet, you got a quiz on the vocabulary, and then you'll have something on arc and arc length. So you'll use this formula. Let me put a little box around it. And that formula. Know that circumference is 2 pi r. All right, have a good day.